Welcome to Brain Vision.
For this question, we have to consider the impulse on the reflecting surface. So, for first, we need to write the formula of the impulse, which relates force and impulse. So, force is equals to change in impulse divided by the change in time, or del t. And impulse can be taken as the change of momentum. So if we consider this to be a mirror, and a photon is just hitting this surface and bouncing back with no loss of energy, so we can say that the initial momentum mu is equals to the final momentum mv, which is of course in the negative direction, so there's a negative sign. So the the impulse should be twice the momentum, which is, if you consider 2 mv divided by del t. And for photons, we can use the formula which relates momentum and energy, which is 2 energy by speed divided by del t. And from this part, we have to be a bit more intuitive, as we have to manipulate the terms a bit. So if we just take uh, del t on top and take out c here, we see that the energy by del t can be written as the power. So 2 into, let's use another color to highlight this, and power by c. And since we have been given the intensity and the area of the surface, we can use the formula for intensity, which relates power. So the formula for intensity is I equals to power by area. So we can write power as intensity times area, with lie and with the two multiple, and see, if we just plug in the values, we get that the force is approximately about 9 newton.